Also, I would suggest when you do the assignment for today, the classwork, we will do all or at least most of it in class together. So try to take notes. So that one you'll have done and finished. All you have to do is get it turned in or take a picture. Also, I would suggest that when you work the regular homework for this thing, I would try to do it within 24 hours while it was fresh. That's at least my advice. Well, let's get started. I'm going to share the screen, look at the topics for today. We're going to look at functions versus polynomials and how they're connected and some common things that you'll see all right. Marco.
Hello.
Okay. First thing we're going to look at is polynomials, and then how do they turn into functions? What is the difference? Is there any difference? How does that work in mathematics? What's commonly seen on that? Second, this morning, I'll do examples of one of the things that they'll ask you to do quite a bit with polynomials is to factor. There's other things as well, but you should be familiar with that. But if not, it's time we see a little of that, factoring polynomials. Then we'll look at a specific type of polynomial, quadratic polynomials. That means there's a squared term, and what are some common things that we would be asked to do with those in a variety of ways. And then a little review if we have time for the things in the past. So functions versus polynomials. Let's get right into it. Polynomials, here's an example of two different ones. Here's a binomial, and here's a trinomial. They're both considered poly, which means many nomials, groups of numbers, the polynomials. The things that I hope you're already familiar with, how you add, subtract, multiply, and divide those. It might be as easy as 3x plus 7x. That's adding two monomials, that's 10x. Okay? Factoring is maybe not quite as easy. We're going to look at that here in just a little bit, but we can also add, subtract, multiply, and divide. Today we want to look at factoring polynomials. Notice on these two polynomials that are given, they don't equal anything. What does it equal? They're just an expression. In polynomials, they don't really equal anything. We're just asked to do different things with them. A very common use of polynomials is to make it a function. In other words, we'll say it equals f of x. Another name, if that bothers you, just say y. They're commonly exchanged with each other. So f of x, g of x, t of x. So why don't they just say y when they do that? Sometimes they want to give them names. For example, a real common function is cosine function in trig, and they give it a specific name. Now, most of you haven't had trig, but if you have had trig, or at least introduction to it in geometry, you would know what cosine means, because that's a specific name. Just like when you say Mr. B, well, most of you know that you're talking to me probably, okay? It's just a way of naming things so you can tell them apart. On your calculator, it's y1, y2, y3 when we graph or set something in the polynomial part of our calculator. Okay. And I've given an example of both. F of x is a binomial. G of x is a polynomial. As a general rule, they use the first half of the alphabet. In other words, it wouldn't surprise me if they said b of x or h of x. It would surprise me if they said x of x. That doesn't usually happen. There's no hard, fast rule, but usually when they name them, it's the first half of our English alphabet. Okay, what are some of the things they want us to do? Well, a very common thing is to plot points or find a specific value. For example, what's f of 3? Well, I know, I'm talking about this one right here. And it says in that function, you double the number and add 5. Well, I know how to double 3. And I know how to add 5. The answer is 11. Now, if I had to do 2 or 3 of those, I would do it by hand. But if I had to do, say, 100 of those, I would go to the calculator. You say, well, why would you want to do 100? Well, there's reasons for it. For example, in calculus, when I'm doing limits and I want to get really close to a number, I might do it 100 different times. I don't want to do that by hand. I'll do it with the technology. But here, all it says is double and add 5. G of -2. Well, that one tells me I'm looking at this function here. It says square. Okay, so I have a -2 squared. I'm going to write it down. It says 5 times the number. Okay, 5 times -2 minus 1. I use order of operations. -2 squared is 4. 4 times the -2 is -10. $4, spend 10 is a -6. Spend $6, spend $1, you spend 7. So the answer here to that one's -7. All it is a point. It's the point -2, -7 on this polynomial. It's a trinomial. There's 3 different terms. It's the same thing as plotting points. And I'm hoping that you've seen this before and it's just a little review, but if not, it's time you're exposed to it. See if you can do that one without me telling you. What is f of 4 plus g of 3? Give it a try. See if you can come up with a number for that. Well, let's see if we can do this step by step and agree on answer. F of 4 is some number. And it says by definition that I double 4 and add 5. So that's the first number is 13. Next, it says g of 3. Well, I've got to do all this. So 3 squared plus 5 times 3 minus 1. 9 plus 15 minus 1. $9 and $15 is $24. $24 spin 1 is $23. And that is 36. So there was a case where I could find numbers and plot points. And that's really 2 points, and we're adding the points together, which is the reason we might do that. Here we're just saying, can you do it? Try the next one. Try a little multiplication one. Same 2 functions. What is g of 5 times f of -5? What's g of -5? What is this? And then multiply it by f of -5. I wonder what that would be. It's a certain number. What number is it? Give that a try. Well, let's see if we can do this one step by step. Does anybody have the answer? You have an answer? Need more time? G of -5. Well, G comes first this time. So I'm going to say -5 squared, because it says to right here by its definition, plus 5 times the -5 minus 1. -5 squared is 25. 5 times 5, -25, because one of them is negative, minus 1 equals a -1. 25 minus 25 is 0, minus 1, -1. So the first number I have is -1 times f of -5. Well, now I'm looking at this function. 2 times -5 plus 5. That's -10 plus 5 equals -5. Negative times negative is a positive. 1 times 5 is 5. Questions on that one? Questions on that one? And there's other things we could do for it as well. We could check them as well by doing the algebra as well. That's a different class as well. Any questions there? Okay, the next topic I want to talk to you about is factoring polynomials. The first thing we did, we took polynomials and we turned them into functions. That's not the only type of function, but that's one we're using here. But now we may be asked to factor polynomials. And that's kind of a strange thing to do, factoring. And the reason it seems awkward, when you were first taught about numbers, you were taught to unfactor. In other words, if I write that on the board, I didn't tell you to do the problem, but all of you have already done it. You can't, you say, well, it's this right here. I was taught to do this. This is usually what we want to do. We want to go to the most acceptable answer. This is called factoring, breaking it up using multiplication. And we want to, here, today, I want to look at 2 spatial types of factoring formulas. Hope that you've seen one or both of them before and it's a review, but if not, it's time we saw it. So there's all types of different factoring. But today I want to look at spatial formulas, a couple of them on factoring. And all factoring means, again, is can you break it up using multiplication? Okay, the first one I want to look at is difference of perfect squares. It's a spatial formula that's always seen, it's always asked for. And the perfect squares that you see here is x. And it's a difference, it's called difference. It's a subtract right here, subtract difference of perfect squares. Perfect square for 16 is 4. And when you have a difference of perfect squared, it's square plus square, square minus square. I'd be surprised if you're not already familiar with that. You should be, and it's always used in a variety of ways. Here's another one. Say I had h squared minus 25. I hope that seems like an easy problem for you. It's a difference of perfect squares. It's h plus 5 and h minus 5. And if I multiply that out, those polynomials, it would give me what I have here originally if I did the FOIL on this. Let's look at another one. Difference of perfect squares. On this one, they don't look like perfect squares. What they would want you to see on this one, if this was on the ACT, is you can factor out, oh, I can factor using the distributive property. And once you do that, you see, oh, it is the difference of perfect squares. My answer here is 3 times x, perfect square, plus 2, and x minus 2. Now, there's reasons why we want to factor. Right now, we're just saying, can you factor? Can you break it up? So I've written this subtraction problem as a multiplication problem. So I factored it. And again, there's reasons why we want to use this, but it's something we should be familiar with. Difference of perfect squares. Now, sometimes they get a little more involved. And it's kind of tricky with the perfect squares. For example, say I had h to the 4th power minus 64. Well, those are difference of perfect squares, and that would be h squared plus 8 and h squared minus 8. In other words, the perfect square here is h squared squared. That's h to the 4th. So sometimes you got to think a little differently to get perfect squares, but it's used quite a bit. And we'll work some more problems with it here on the classwork here in a second. So that's one special formula, difference of perfect squares. The next one, difference of cubes. Now on squares, it always has to be a difference. It always has to be a subtract. On perfect cubes, it can be a plus or a minus. For example, I say, oh, I see this one is perfect cubes. It's x cubed perfect and 2 cubed perfect. So it's a difference of perfect cubes. It's also a special formula. And it would be cube minus cube. All I did was look at what the perfect cubes are here and subtract them. Times cube squared to start with and cube squared to end with. I just squared those. Sign change, that's a minus, so I always change the sign when I do this. It becomes a plus. Their product, which is 2 times x. And that's factored. I took a subtraction problem right there, a subtraction problem, made it a multiplication problem. And that one you may or may not be familiar with as well, but it's used more and more. See it more and more mentioned on tests. Let's do another one of those. Difference, or could have had a sum. Now, if that was a plus, this would have been x plus 2. Everything else would have been the same, but I wouldn't change that sign to a minus. That second sign is always changed. Now let's look at another one. Okay, this one is a sum of cubes. The cube here is 3 cubed. The cube here is 5. Take a look at that and see if that makes sense. See if that makes sense. So if I went by that pattern, it's a special formula. I don't have to think about it. I can go to the answer. In other words, it is 3 cubed plus 5. Notice I didn't change anything. It was a plus. I left the plus. I took the perfect cubes. Square the first one. So I squared 3 cubed. End up, I square the last one. Well, that's 25. Change the sign, so that goes to a minus. Multiply. 3 times 5 is 15 in the cube terms. So a sum or difference of perfect cubes. And we'll work one of those here in a second. So the objective there was to look at and there's all kinds of special formulas. These two are used most often. Sum of perfect squares, difference of perfect squares, and sum of difference of perfect cubes. Polynomials is quadratics. Polynomials, that's quadratic. And here you could do several different things. What I want you to know here, and it's just used in so many different ways as quadratic formula. Now, if I was solving this polynomial, which is a trinomial, 1, 2, 3 different terms, I could use all kinds of methods. Okay? I could factor, I could use quadratic formula, I could complete the square. So let's take a look at the quadratic formula. It's one you should, again, be familiar with, but if not, let's get it down. The answer to this problem, x equals, I'm looking for some number that makes that true. Well, it says that number, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. And it's all over 2a. Hope you've seen that before. And on this problem, sometimes it's not a bad idea to write it down. But a is always the square term coefficient, 1. B is the x term, or the non-square term, that's 2, coefficient. And c is the constant term, whatever that coefficient is, and it's -8 here. So if I wanted to solve this, I would put these numbers into that equation, in the way it's written out. So I would say the opposite of b, well here's b, 2, so it's -2, plus or minus big square root, b squared. Well, I know 2 times 2 is 4, minus, so always the second one is always, this is always a 4, times a, which is 1, times c, which is a -8. And it's all over 2a. 1 times 2 is 2. Well, that's the solution, but they always expect to use order of operations, PEMDAS, to simplify. So I would start inside the square root, and I would start over here. The very last thing is the first thing you do. 1 times 4 is 4. 4 times 8 is 32. Times negative is a positive 32. So I have 4 plus 32. So -2 plus or minus the square root of 36 over 2. Well, we know what the square root of 36 is. So I have -2 plus 6. And I have a -2 minus 6. $6 spin 2 is 4 over 2. So one of the answers we have is 2. Negative minus a negative is a -8 over 2. So the other answer we have is -4. So that's taking a polynomial and using the quadratic formula. Now, if you factored this, if you can factor it, we just talked about 2 spatial formulas. If you factored this right here, you could solve by factoring. It is x plus 4 times x minus 2 equals 0. And both on factoring and quadratic formula, it's important that it equals 0. Well, if this is 0 right here, it's -4. If this is 0 right here, it's +2. So you can factor as well if you want to, but sometimes factoring is not as easy as a quadratic formula. The quadratic formula is used over and over and over again in all kinds of different ways. Well, let's work the second one together. This one doesn't factor very well at all, but I see a is 1, b is 8, and c is -3. Now, it wouldn't matter if it was written like this, 8x minus 3 plus x squared equals 0. A is still 1 even though it doesn't come first. In other words, you're expecting to know that a is a squared term, c is the constant term, and it must equal 0, which it does. Well, again, I would take the equation and just start putting the numbers in here. What's the first one? Can you tell me what the first one is? You got it in your head? -8. Plus or minus. What's the next number that goes here? B squared. What would that be? Did you say 64? Minus 4. A is what? 1 times C is a -3. What's it all over? 2A. Go ahead and take about 10 or 15 seconds. Simplify the square root. What is that square root? It's -8 plus or minus some square root. What is it? See if you can get that in 30 seconds. $76. Do we agree on that? We agree on 76. 4 times 1 times 3 is a positive 12. 64 plus 12 is 76. And they would want you reduce. I would take a 2 out of 2, which leaves me with a 1, which is in the denominator, wouldn't always write it. A 2 out of -8 is a -4. But when that 2 comes in here, it's really a 4. And that would be 19. So the answer is, my goodness, no wonder I said I don't think I could factor that. And I would certainly want to check my arithmetic. Quadratic formula. A polynomial, there's a polynomial, equals 0. It's very common. Solving quadratic equations. Well, the last thing before we go to classwork, let's do a review. Let's do a problem that we've already had on homework. Hope you know how to do it. See if we can still do it. What is the approximate area of this circle? Everybody do that on your own. Let's take about a minute on your own, then we'll see if we work together. There's a circle. It even said it's a circle. It's a circle because there's 2 squared terms and they're balanced. What is the area of that circle? If you get the area, and we haven't started back, try graphing it. Try graphing this circle too. Okay, let's take a look at it together. The area of a circle, they expect you to know that equation. It's pi times radius squared. Oh, look, these are both completed squares. They are both factored. Oh, they're both factored. This is x plus 3 times x plus 3 and x or y times y. The radius is the square root of 25 or 5. So the area is 25 pi. And I believe that's around 78 approximately and a half units squared. If I get the area, if I would graph that, do you remember how to do the center? The center is at -3, 0. I put it in red, -3, 0. And then you go 5 in all directions. Right 5, left 5. Up 5, down 5. 45, 5 in all directions. Now, Geometry is probably one of my favorite topics in math because I can see if it makes sense or not. The area I have mathematically, without looking at the graph, is a little less than 100, 78. Now I want you to look at the first quadrant. That's 10 by 10, that's 100 square units. 10 by 10, 100. Each of these are 100 square units. So that means there's 400 square units there. Does this shaded area look like it's a little less than a fourth of it? Oh my gosh, it makes sense. I get it. And that's why I like geometry so much. I can work the mathematics with the symbols, and I can come and actually do it and say, yeah, that really looks correct. Let's go to the classwork. Go to the classwork. Those were some examples today. Here's examples of the homework that you might see. First example, it says g of x is this. What's g of negative 1? Well, they've given us answers here. And it says select all that are true. So g of negative 1 and 4 is 3 squared plus 6. 9 plus 6 is 15. Does that make sense? Oh, but what about these two right here? I need to look at those. If I put a negative 1 in here, okay, g of negative 1, that's what was given, so it's g of negative 1. I'm going to circle it as well. It's the same thing. What about negative 7, g of negative 7? Negative 7 plus 4 is a negative 3 squared. Oh my goodness, there were 3 of them that all turned out the same. The only one that didn't work was 20. I see more and more of this on the test. They give you more than one correct answer. I don't like it, but they didn't ask me about it. They should have asked Carissa, because she would have told them, quit doing that. Just quit it. Okay, second one. So number 1 on the classwork for today is A, C, D. All of them work. A, C, D. What are the factors of this polynomial? Well, first off, you can take a 5 out of everything and have x squared minus 4. Oh, difference of perfect square. I took a 5 out, and right there's the answer. There it is, factor. Difference of perfect squares. Number 3, what's the approximate area of the circle? Well, we just did that one. It's pi times radius squared, that's 16 pi. And they don't have 16 pi. 3 times 16 is 48. It's got to be around 50. You might want to check my arithmetic on it. Is that right? 3 times 16, 30. So it's got to be around 48, 49, 50. 50 is the only one that makes sense. Approximately. Quadratic formula. There is a polynomial, trinomial. Solve it. Well, we spent some time on that this morning. Is it in the correct ABC form? Sure is. Opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. 36 inside the square root, 36 minus 8. So I have negative 6 plus or minus the square root of 28 over 2, and that's none of the answers. Oh, we can take a 2 out. Take a 2 out. Take a 2 out, negative 3. So those two are out. And that would be 7. It is this right here. Marco.
Hello.
Oh, I can't hear you.
Hello.
Okay. My internet connection kind of flickered. I was a little. So the answer to number 4 is B, negative 3 plus or minus the square root of 7. And there, I would have taken forever to try to figure out what the factors are without this quadratic formula. Next part on the classwork for today. What are the factors of this polynomial? Oh, difference of perfect cubes. Do you see the cubes? It's x and 3. X cubed, 3 cubed, 27. So my answer should be x minus 3. Square the first one for the first one, square the last one for the last one, change the sign, and multiply them together. And if I care to start foiling this or multiplying it out, it should equal this right here. And to me, that was amazing. I always question, in other words, I always want to start doing the FOIL and see if it works. But if you do the FOIL, it really works. Number 6. What is f of negative 4 plus g of negative 2? Okay, f of negative 4. Negative 4 squared plus 3 times negative 4. Negative 4 squared is 16 minus 12. $16 spend $12 is $4. Save that answer. G of x, g of negative 2, so that's 3 times negative 2 plus 4. Minus $6 plus $4 is a minus $2. And it says to add those, so 4 minus 2 is 2. And we have an answer. It's D. Okay, and the last one. What is, here's a product, f of 1. So f of 1 equals 1 squared plus 2 times 1. 1 plus 2 is 3. And then g of negative 2 is the absolute value of 3 times negative 2 plus 4. That's a minus 6 plus 4. That's a minus 2, and the absolute value minus 2 is 2. And it says to multiply those. 3 times 2 is 6. Answer is B. Questions? Anything I need to go back to? Any questions? Any questions? Please try to do these within 24 hours and you won't get behind, because if you, at least for me, when I get behind, if I'm 1 behind, that's not so bad. But boy, if I get 3 or 4 behind, it seems overwhelming. So try to work these out within a day of when we have them. Is there a question? I'm going to stop sharing the screen then. Beth, is there anything you want to say? Anything you need?
I would just tell them to make sure when you're turning this homework assignment in, it's not that we're just wanting the answers to the questions. We want to see that you've worked them out. So make sure you're not just giving me A, B, C, D, that you're actually giving me step-by-step process.
Just like what I'm doing, and sometimes I'm not as neat as possible, so it might not be a bad idea to do A, B, C to show the different steps. Carissa, anything you want to add? John?
No, sir. If that's all you have, we'll see you all at 2 for afternoon class.
Okay. Bye-bye, everybody. Bye-bye.